Hi everyone. So today we're going to be looking at the capillary rise between two vertical plates when we stick them in water, and we're going to change the temperature and see how that affects the rise. So the materials that we're going to be using for this experiment are some blue food coloring, 3 glass microscope slides, a ruler, a small glass dish, a thermometer, and some blue painter's tape. So first, what we're going to do is take our 3 glass slides and pull the middle slide up a little bit so we create 2 vertical plates with a known distance between them, that distance being the thickness of 1 glass slide. After that, we are going to tape them to a ruler so we can measure the capillary rise when we stick it in the water. We're then going to fill up our glass dish with some water that has been dyed blue. We then record the temperature of the water and slowly lower the glass slides into the water, monitoring the capillary rise. After, we are going to then heat up the water and essentially repeat the experiment and monitor the rise with the heated water. So this is our experiment when the water is at room temperature. And this is the experiment with the heated water. So here are the results from the experiment. The room temperature water at 20 degrees C gave us a capillary rise of about 1.1 centimeters, and our heated water gave us a capillary rise of about 0.7 centimeters. These values were calculated by first measuring the depth of our glass dish and then subtracting the overall height that the water rose on the ruler to calculate the actual capillary rise. So using our capillary rise equation from our textbook, H equals 2 gamma cosine theta over rho GD, where gamma is our surface tension, theta is our contact angle, rho is the density of our liquid, g is the gravity, and d is the distance between our 2 vertical plates. This equation, however, is only true such that the bond number is significantly less than 1, so we will also be calculating the bond number for each scenario. A couple of things that we know about our experiment. Because we're using glass, we can assume our contact angle to be 0. Our surface tension when water is equal to 20 degrees C is 72.8 millinewtons per meter and 63.6 millinewtons per meter when the water is 75 degrees C. Our densities are 998.2 kilograms per meter cubed when our water is at 20 degrees C, and 974.8 kilograms per meter cubed at 75 degrees C. I also measured our glass slide to be about 1 millimeter thick. So solving for the capillary rise of the water at 20 degrees C, we get 1.5 centimeters with a bond number of 0.13. And the capillary rise of water at 75 degrees C, we get 1.3 centimeters with a bond number of 0.15. So in conclusion, I think a thinner gap between the two vertical plates would result in a more accurate capillary rise versus the theoretical value, as this would result in a smaller bond number, where from our textbook, the bond number must be significantly less than 1 for this capillary rise equation to hold true. Another source of error is possibly that between me heating the water and taking its temperature and actually conducting the experiment with the glass slides, the water most likely cooled down. But overall, I view this experiment as a success, as we could physically see that the hotter the water, the lower the surface tension is, because of the significantly less capillary rise that occurs with hotter water versus our colder water or room temperature water. Thank you.